Hey everyone, so I am Muddassar, and this is going to be my short talk on cost benefit analysis of for businesses when it comes to fine tuning LLMs or deciding between fine tuning and other techniques out there in order to get to the final result that the use case company wants to solve. So, like the most like in every use case, like the central question that every business operations or stakeholder needs to answer is it possible for us to use just pre-trained models that are out there from OpenAI, from Claude? The reason being is because they are out of the box. There is no need to do any fine tuning there. They are fast, they are affordable, and the next most important question is, for example, like in our use case, what is our use case? And in our use case, is there a need for any data that is not public, that is private? So you want LLM to go over that data, understand patterns in that data in order to answer some really important question here, or call some really important function or tool if you are building an agentic AI, and then based on that do something. So that's where if you have your own private data, is it required or not? That's a really important question that every stakeholder needs to answer. And then based on this answer, let's say you do need your private data in the entire use case you want to resolve, then the question is, do you fine tune your model on that data, or do you just every time you want to answer some question, you go and you retrieve the most important bits and pieces of your private data, and then you just add that in the model without fine tuning it? So these are two different outside techniques out there where you can use your private data. So I feel like to answer this question on what do you choose, do we choose fine tuning or do you choose RAG, where you retrieve the most important bits of data and then use that as context in the LLM? I think like it's really important to first of all understand what is fine tuning and what the fundamentals are in order before we can easily answer this question. So the fine tuning is all about adjusting the weights of the model with the new weights, and the new weights will have knowledge of that private data as well. Fine tuning also means, for example, you have to modify how the models behave. The models need to unlearn something or relearn something because you want model to like just focus on your data and then forget about the past. And the way LLMs or any deep learning models work is as you train and keep on training, the latest training always has a precedent over the old one. So if you take a LLM or large language model that's pre-trained on some natural language data, let's say if I just fine tune that on medical data, that LLM will eventually like be more focused or learn more stuff about medical data. And in order to do that, it will also unlearn some of the stuff that it learned before. So fine tuning in a sense will update your model. It waits. And there are two things that, and then within the fine tuning domain, there are two ways that you can fine tune. Number one is like you update all the weights, every layer of your model, which is really expensive, by the way, because let's say the models that we have right now out there. So one way to fine tune is like find just updating in all the weights right now that we have in our model, which is really expensive, by the way, because as I said before, large models, they are really big. They have 150 billion parameters, right? So let's say if you want to go and update or the entire model, you need a really big hardware setup, which is really expensive, by the way. And the other way of fine tuning, which is also provided out of the box by OpenAI, Claude, and other companies, is just fine tuning a few layers towards the end. It's called parameter efficient fine tuning because, like, you're only, and then here you're only fine tuning the last few layers. The advantage being is like the last few layers will be able to retain the knowledge that or learn from your own private data, whereas all the other layers in the model, which are already trained on other aspects of language, for example, grammar and other stuff, and then emotions. So all that knowledge you still need, right? So that's the overall idea of just fine tuning a few layers. And normally that's much cheaper, that's much faster. You can, if you have a small amount of your data, you can easily fine tune it, and then the cost won't be super high. The time requirement is also pretty low as well. And then you can move forward. So if I just recap everything right now on prompt engineering and then fine tuning and RAG and then from scratch as well. So if you are fine tuning the entire model, then it's same as like building the model from scratch. It's not same as, but in the end, for example, like since you are, it's like building the model from scratch because like you have to update so many different layers and weights in the entire model, and then you will end up having your own custom model which you will have a full control over. But in the end, like it's gonna be really expensive to train it from scratch and then maintain that on the server. Training from scratch is really important that way. If you have terabytes or petabytes of large amount of data, and then you know that you won't be able to get the results by just fine tuning the last few layers, you need to like train majority of your entire model. And then in the end, the other important consideration here is that let's say you want to keep your model private as well. So from scratch or taking the open source model and then retraining it on your data makes a lot of sense. Let's say if you have a very small amount of data and then you are not concerned about privacy, or if you are even concerned about privacy, based on the privacy factor, you will decide to either use an open source model or you will use the closed source one, for example, OpenAI, Claude. And then once you decide the closed and open source model, since you have small amount of data, then fine tuning the last few layers makes a lot of sense. And then as a result, you will see that, for example, the model will be better able to answer questions in the domain of data that you have given. Let's say if you have given a really specialized data on health tech, for example, then you can expect a fine-tuned model to answer health tech questions better than the model that's not fine-tuned. And then, for example, why would you not use fine-tuning? Let's say your data is evolving a lot. Just to give one more example on when you should use RAG over fine-tuning is, let's say like you have an LLM or an AI agent which buys and sells stock based on the news. Since news is evolving and everything is evolving, it makes no sense just to fine tune the LLM on all the news. It makes more sense to just retrieve the latest news in seconds and then use that as the context for the LLM to answer really important question about whether to execute a trade or not. So in this case, you need up-to-date information, and fine-tuning is not going to be feasible because you need to execute the results really fast, and then the data over here is also changing over time as well. So we can talk about more about RAG as well. There are multiple types of RAGs which work in different use cases, and this is something that can be part two of this talk or in the future as well. And then the last point over here is like prompt engineering, which is pretty much like that's all about, for example, adding some context in the prompt where you think you only have a few small contexts that you want LLM to take into account when answering a question or doing some task. And that context is pretty small, then it makes sense to just add that context in pretty much like your own system prompts. So in short, like you add your small context and system prompt. If you have data that's changing a lot, then it makes sense to retrieve that data through RAG. If you have a really, if you have a decent amount of data on some domain and then you want to fine tune LLM to work on that domain, then fine tuning makes more sense. And then, for example, like if you have large amount of data, then going for building your LLM from scratch makes more sense. And then, of course, for example, every method that we discussed just now has different costs and everything. For sure, if you are training from scratch, that's going to be a really big hassle for sure. Fine tuning is a bit cheaper. In fine tuning, the most important thing that you need is the compute resource you can easily have, right? There are so many different, even if you are using OpenAI, they provide you with a way to fine tune OpenAI models. You don't need to care about compute resources over here. For sure, they will charge you more per token for the model which is fine tuned versus the one which is not fine tuned. But in the end, like the compute resource won't be too much. If you want to fine tune an open source model, then for sure you have to think about compute resources. The most important cost will be in data preparation because like if there's a certain format that data needs to have, and then let's say if your data is spread around, it's in bits and pieces. So compiling data collection preparation is something that takes so much of the time. And that is where you need also manpower, and that is where you need an investment into engineering as well. And then, for example, so fine tuning is not just a one-time thing. It's quite possible your data is changing every 3 months or every 4 months or every 6 months. Depending on that, you have to also keep on fine tuning as well. So you need to have a schedule for fine tuning your LLMs. And speaking about the hidden cost here, the most important thing is like the delayed implementation because there's data preparation involved and then there's also fine tuning involved, which can take a few days depending on the size of data. And then, for example, the most important thing is, for example, maintaining that custom model as well. So yeah, that all adds up. But if your use case is a use case where you want your model to be an expert in a really niche domain, and then you have your own private data as well on that domain, then fine tuning is a way to go. And then the benefits will way more than the cost and everything as well. As I said before, the cost reduction, pretty much like what I see everyone doing. People don't retrain or fine tune the entire LLM because that's super hard. In fact, they always go for an approach where they only fine tune one part of the model or last few layers of the model. And then as a result, we have seen that's much quicker. You don't need as much hardware as you required before. Number three, your knowledge of your custom data will be, so model will be better able to learn that knowledge from custom data. And then that knowledge will be stored in a few layers in the model, which is even better versus spreading your knowledge about your custom data around 65 billion parameter model. That's pretty big. And then we have, I would say, a couple of tuning things, for example, as well, fine tuning techniques right now out there. So yeah, like last few layers is a way to go always. And then moving on towards like the ROI pretty much, the entire ROI equation depends on multiple things. For example, how periodically you not wanna retrain everything after 3 months or 4 months. What's the inference cost? It's quite possible that if you are using LLM, the inference cost of a fine-tuned model is way higher. That's pretty important. And then the initial fine-tuning, where you have to prepare data, is really important as well. So all these things, factors, once again, will go into your equation to find your ROI, what's the cost, what's the advantage out there as well. In the end, on average, I would say it's 20% or 15% the cost is higher for a fine-tuned model than the other way around. So if your advantages or the benefits you will get out of is more than that, then it totally makes sense. And then speaking about the benefits, they are quite a lot. For example, if you wanna have LLM be an expert in a domain, then fine tuning on that domain will give you 15 to 30% more improvement in the accuracy of results compared to out of the box LLMs from OpenAI or from Claude and from other vendors out there. The next most important thing is, for example, as the model has more knowledge about that domain, and that knowledge is fed into a few layers of the model where the model can go and fetch that information. We also see around 50-60% less hallucination. So in the use case where you need higher accuracy, fine tuning is a way to go here as well. Yeah, moving on, for example, like since you have spent fine tuning, you don't have to pass as much context in your input or system token. So as a result, you can also, there are cases where you can expect to have less inference costs just because like you need to use less tokens. And then if reasoning is really important for you, since you have better, more context, and so reasoning that you will get out of LLM with the output will be also much better than before as well. And then the other benefits that are extremely important to consider here are, like, if you have your own fine-tuned LLM on your own proprietary data, that also gives you an advantage because that's your own IP. That's the own unique model and expert in some domain that you own as well. This is something that will surely go on to your asset books of the company, something that you can easily think about leveraging or selling or even like licensing in the future as well. That also gives you a really huge advantage over everyone. And then, for example, if you are fine-tuning on the open source model, it's quite possible that the fine-tuned model on your domain, on the open source one, will perform much better than any out-of-the-box top models out there from top vendors. And then in that case, like you will end up owning everything, that owning the entire LLM, a really big thing, which is an expert in that domain. And then, for example, like if you're going with an open source route as well, there's also the advantage of Enhanced security means your sensitive data, your LLM is going to be trained or fine-tuned on, will stay within your system, and then that's a much secure way of doing things. That's really important if you are in a healthcare space or a government organization that totally cares about your data as well. And then, or if you are in the industry where data is really important, you can't share. So for compliance reasons, you have to go with the open source one as well there. Uh, and then I've also compiled here different metrics or different that people reported. For example, like how fine tuning was able to help them get better results in different domain. For example, yep, LLMs are trained over wide array of data, of language data. Legal data is a bit different. You have a different lingo. Like a person who hasn't gone through a law school will surely have a problem reading all really big legal documents, right? That is also the case with out of the box LLMs. They are really good, but they do struggle sometimes. That is where like the legal profession has found that if you fine tune these models on the legal data, you do get better results. The same also goes for the healthcare. It's much better. Also, the financial services, for example, if you have your own proprietary data that you want to train the model on, that's much better as well. Maybe you have a model to execute some trades as before, and then in that model that execute train, one really important input is like what's happening in the entire world based on news and all that stuff, and that's where LLM can easily come in. And then the fine-tuned model will be able to pick up patterns from the world much better as well. And then in manufacturing, fine tuning is super important here if you are. And then at the same time, all the AI agents providers in customer service out there, they have also found that, for example, fine tuning LLMs to better understand a business for a client makes the LLM perform better and gives them the competitive advantage or edge over everyone, other vendors out there, because here you are building your own mini LLM that understands your business. And then if you are providing your customers with that, a really personalized LLM for customer support, they surely will get better results than can get from other AI customer support vendors out there. And so because you have better results, which are the most important metric out there. What are some different technical considerations if you are a tech person going over this fine tuning, RAG, and other stuff? So the most important thing is, as we discussed before, is open source or closed source. It's data. Like, do you want to train the last few layers or the entire model? That's really important to consider as well, as I discussed before. And then if you're going for the RAG architecture, given that you need that data in real time, that's evolving as well. They are some of the most important techniques I've found so far are here. There is a different concepts that you want to understand. This is something that can be some other talk where I go into detail on different RAG techniques out there. So lastly, on a really high level comparison between RAG and fine tuning, the cost for fine tuning is fixed, where for RAG, every time you call an LLM, you might want to call a RAG to fetch relevant information from your databases. So you have a real-time cost for sure. So initial cost is really high with fine tuning. With RAG, it's much lower. With fine tuning, you always have to retrain or refine tune after the interval once you get more and more data. And then for RAG, you just have to update your knowledge bases every time the LLM needs to extract some information from knowledge bases, LLM can extract the real-time, up-to-date information as well. For sure, for example, in the RAG pipeline, like you have to call RAG, you have to pass that to LLM. And then when you call LLM, you also have to add RAG data tokens into LLM. So you have more token usage, so you have a really higher latency as well compared to fine tune. Reasoning, it's better or even same with the both techniques as well. In terms of infrastructure, you need a different infrastructure in both cases. If you are using out of the box LLM providers, there's no infrastructure required because they just want you to provide them with data in some certain format. And then once you upload data in OpenAI, it just does the fine tuning for you. There's no need to build or maintain anything at all on your side. On the other hand, for the RAG, you do need to build your vector database to store your embeddings. And pretty much there is some investment required there as well. I think we already covered data sensitivity as well before. So in summary, you will choose fine tuning when the knowledge is not changing rapidly. You have a really high volume of query, right? And then it makes sense to fine tune it versus using RAG because like you have a really high cost. And then you will use fine tuning more when you have really large amount of domain knowledge that is required by the LLM to answer a question, right? That there. And then in the end, for example, like you need really fast results, like you need a really high accuracy result. That's where you will for surely go for fine tuning as well. And then you will choose RAG where the data is evolving by a lot and you need to extract relevant data in real that's evolving in real time. You also use RAG, for example, if you want to citations, right? Fine tuning, LLM won't know which document had that information that LLM learned. But with RAG, since you are adding extra knowledge required by LLM in the context, LLM can easily cite as well. If you need citations, then RAG is the way to go. And you will use RAG if you have only small amount of data. That fine tuning won't make any sense. You're like, hey, I'll just add that data in the context as well. And then once again, like you don't want to spend so much time initially fine tuning. There's no budget. That's also where fine tuning is a way to go as well. I do also have a few right now case studies that I have mentioned here. I will be adding the link of this artifact as well, so people can easily learn from it. So once again, key takeaways, like we have different techniques out there. There's fine tuning. There's fine tuning only a few layers. There is RAG. So depending on different scenarios, every technique is really important, right? So we learned that fine tuning can be something of an investment where you will end up building your own proprietary model that works really well in the domain you operate in. This is something that you can license in the end, in the future, or sell. That's an asset that belongs to you. We also learned that there are the costs, the direct cost of fine tuning is the initial cost that you have to spend money on where you need data preparation. And then we also learned that there is also the indirect costs as well associated with that. And then fine tuning can be done faster if you only like fine tune a small part of the model, which would also means that your knowledge will be better learned by the model as well, because It's all confined into that small part. And then there is also a possibility that your use case will need both RAG and both fine tuning. It's quite possible that there are two types of information. There is fixed and there's evolving. What's evolving information can become part of the RAG. What's fixed and what's really in high, large quantity data, that can easily become your fine tuning, can be used in fine tuning as well. So, customer support, all the last tickets that were resolved pretty much can be used for fine tuning LLM to tell LLM, hey, that's how you resolve a customer support query. And then the information about policies, refund, what's available in our data, or what's available in stock. This is in the company. This is the evolving information, and this can be part of the RAG as well. So there can be a use case where you need both of these things depending on the context. Yep. So this is on a really high level what this is all about. Why use LLM for, why use fine tuning, and why is that important for every business? Stay tuned for more talks in the future. Bye.